When I look at question number 2, I instantly know what I'm dealing with because they have a question almost exactly like this on pretty much every SAT. This is what I would call a part over whole question, and the reason I call it that is I create a fraction to represent the relationship between the part of a circle and the whole circle, okay, part over whole. And so basically what I'm using is the get back to basics strategy, which means if I can recognize kind of the topic of a question, I want to get something on my page so that I can start working with it because they're going to twist up that topic in lots of different ways, but the essential piece is still going to be the same from SAT to SAT. So I know that no matter what, if I'm looking at a picture of a circle and they're talking about a piece of that circle, I'm going to use part over whole fractions to solve it. Now I recognize that this is a number 2, it's fairly easy, and you might be able to get this just kind of going your own way, and that's okay. But I'm going to stick to my way because I know that on harder versions of this question, I might not be able to be flexible. So I'm going to use my formula because I know it works. Easy, medium, hard, doesn't matter. So what does this do? So okay, we need to kind of compare different aspects of the circle, and so we need to say what they're asking about this arc here, AC, and so I want to think about that AC as a part of something, right? Well, AC is a part of the outside of the circle, and the term that we use for the whole outside of a circle is circumference. So 36 is the whole, right? So AC is the part that I'm trying to find, and the whole that goes with that is the full way around 36. Now, most of the time, when I have these kinds of questions, what I'm going to be doing is finding a way to compare two completely different aspects of the circle. So in this case, I'm comparing the outside distances, and I want to represent that same part of the circle using some other aspect. And most of the time, it's going to be angles. And the reason we use angles is that we always know that there are 360 degrees in a circle. So we know that like we've at least got a piece of what we're trying to, the equation we're trying to make no matter what. And then I would ask, okay, well, if the whole number of angles in a circle is 360, what is a way that they're representing the part that AC is part of, right? And you can see right here, there's this little box, and we know that that means that it's a 90-degree angle. So there we go. Another way to do it is to kind of just recognize that they are breaking this circle into fourths. In this case, they're 4 equal parts. We know that because if that's a 90-degree angle, they're all going to be 90 degrees. But I just want to warn you, like there might be other versions of a circle question like this where they divide it into 5 parts, but they're not necessarily even divisions, okay? So this 1/4 thing might not always work. So let's focus on the part that will always work, this. Once we have 2 fractions set equal to each other, it's just a matter of normal algebra. How would we solve for the missing piece? We would cross multiply and divide. So in this case, it's kind of looks like it's going to be messy, but luckily we can reduce the fraction to 1/4. But also we can see that if we are multiplying 36 times 10 to get 360, we would be also multiplying something by 10 to get 90. And that something is going to have to be 9. So yeah, I could do 360 AC is equal to whatever 90 times 36 is equal to, but I'm recognizing that those numbers are big, and I want to avoid having to do more arithmetic than is necessary on the no calculator section, so I'm using the properties of fractions to kind of reduce and make some things easier. Again, this probably wasn't that hard, but pay attention to this part over whole topic because it will come up on pretty much every test, and it can get very difficult. So you need some way of getting those kinds of questions started, and it's very easy to recognize that if they've given you a picture of a circle and they're chopping it up, in some way you're going to be making these kinds of part over whole fractions. So it's a good way to get the juices flowing and get started on a difficult question. So I recommend when you are dealing with something difficult, get back to basics. That's usually the best place to start, and you'll figure out the rest.